So how do you solve system of polar equation? First step is solve it algebraically, and second, we are going to check it on the calculator. But you have to set up different things on the calculator to see it. So solve it algebraically again. R equals to 2 plus 2 cosine theta, and R equals to 4 cosine theta. So can I set them equal to each other? So it's 2 plus 2 cosine theta, R equals to the same R. So what would you do? Move 2 cosine theta to the other side. So then I get 2 equals to 4 minus 2 is 2 cosine theta. And then divide by 2, divide by 2. So I get 1 equals to cosine theta. So in order to solve the theta, you have to take the inverse. Arc cosine, inverse cosine. So my theta becomes, this basically means what? When does cosine become 1? When does cosine become 1 in the unit circle? Here. And let's say it's from 0 inclusive to less than 360, like 0 to 2 pi. So this will be just what? 0. That's the only solution. 368, we are not including it. So then what is your solution? We write it as r comma theta. So it is r comma 0 degrees. What's the r? How do you find r? You plug into the equation. When it's 0, what is cosine of 0? 1. That's what we've just found. When does cosine become 1? 0, right? So cosine of 0 is 1. So 2 plus 2 times 1 is 4. Is that true for the other equation? Cosine of 0 degree is 1. 4 times 1 is 4. So this is our solution. But for polar graph, remember, even it has the same theta, r can be on the other side if it has a negative radius. So it might look they're intersecting, but it's not a real solution because they go to that point at a different angle. I'll show you by graphing. Or let's first just go ahead and graph it roughly. What's 2 plus 2 cosine theta? It's a cardioid with length of 4, positive cosine, so it will look like 1, 2, 3, 4. Will be symmetrical on the x-axis, so it will look something like this, right? What about 4 cosine theta? It's a circle. What's the whole length? 4. What is the radius then? No, that's the diameter. 2, right? That's not a radius. Maximum radius is 2. I mean, the radius is always 2. The whole length is 4. That's a diameter. That's not a radius. So you see how it does go over 4, 0 degrees here. This is the solution. You see how it looks like it crashed at 0, 0? But it might not be necessarily 0, 0 because it could be 90, 0, 90. It could be other radius at 0 or other angle at 0. So this point where they still goes through, these are called common points. So you can have more common points or equal number of solutions, but you cannot have more solutions than common points. All solutions are common points, but not all common points are solutions. Right. It's like all squares are rectangle, but not all rectangles are squares. I'll show you what it means by the graphing. So go ahead and change your mode to what? Your mode should be already in degrees and polar, right? Because they gave you the windows to work with. degrees, and we're going to change it to polar. And one more thing. When you look at the next two, it says the sequential, meaning they're going to do R1 first, graph first, and then they usually graph the second one after that, right? But we want to look at them together, so we're going to go ahead and change it to simultaneously. We're going to graph them at the same time so we can see whether they crash at the same time. That's a solution. If they just go over the same point at different time, that's just common point. They don't have same r and theta. So for window, let's go to 0 to 360. And to make it slower, let them graph it slowly. Let's change it to 1. To 1. And it will be negative 4.5 to 4.5. Y, negative 3 to 3. You can set up the window by looking at the size of these graphs, right? One more thing. You go to the y. Let's first put the equation 2 plus 2 cosine theta. And 4 cosine theta. One more thing. Instead of just graphing it with the line, we're going to go ahead and change the type of line to point, like a circle. So if it's 83 plus, you can just press enter to change it to this type right here. You see it looks like a oval. Instead of just drawing a line, they're going to show you each point. And press enter. Do the same thing for top. Press enter. Blue is fine. You can keep the color, but change the type of line to oval. Okay? It's going to show you the order pairs. And then go down and hit OK. How do what? Change this. Go to the left and click on it. And change it. Change the type. If you have the black calculators or 83, you can just press enter and it will change it to the different type. Oval. Yes. Mine is 0. Looks like mine is 0. Or it's like a pinpoint. Pin. Like this. So guys, watch this carefully. Watch this with me, guys. When you press enter, it will stop, okay? If it's going too fast, you can stop it. But let's watch this together, guys. Everyone? So graph it. You see? Did you see they started at the same point? That means they crashed. That's a solution. Do you see it? Keep going. Press enter. And it looks like, guys, look at this. They go over the same point, but did it crash? Did it occur at the same time? No, right? That's common point, not a solution. They don't have same r and theta. And then you see it goes around again and it crashed again at 360, but we are not including that for our solution because it's at 360. Okay? They intersect twice. They're both common points here and there. But if they crash at the same time, that's a solution. We have one solution. What else can you do? Go to the table set and make it 0 to 15. And let's check every 15 degrees and go to second graph to look at the table. When they have a same r, that's a solution. You see, you have 4, 0, same. What about at 90? You see the second one, it is 0, 90. But at R1, that was 2. That's why they are not solution. They are just common point. So here is the solution. And for the common point, it includes your solution all the time. And as you can see, there's one common point. There's so many different names for this point. Just go ahead and give me the closest to 0. So what's the radius? Radius must be 0 at this point, right? It looks like 0, 0, but it's not always 0, 0. So where is it? When does r become 0? 90. So what is the common point? 0, 90 will be the common point, that's not a solution. This should still work for one of them. It won't work for both, but it should work for one of them. That's why you cannot just put, oh, this is 0, 0. If you look at the calculator, it was 0.90. Okay? Let's do one more. So here, please go ahead and read this note. So solutions are when they crash at same r and theta. Common points are where they intersect, but including all the algebraic solution with non-solutions, okay? So let's do just one more. R equals to 2 theta. You should know it's a circle on the y-axis, positive y-axis, and the radius will be what? 1, because the total length is 2, right? This is the total length, diameter. Radius is 1. What about 1 plus 1 sine of theta? That is cardioid on the y-axis, positive, and the total length will be 2, 1 plus 1. So 1, 2. So it looks very similar to the one that we had, right? So how many common points would they have? 2 for sure, but we don't know if the solution will be 1 or 2, or it could be none, right? So let's go ahead and solve it algebraically first. 2 sine of theta equals to 1 plus sine of theta. So move smaller sign, subtract sine. Subtract sine theta. So you get sine of theta equals to 1. So when you take inverse, basically means when does sine become 1? If you're looking at from 0 to 360, excluding 360. So in the unit circle, when does sine become 1? 90. So your answer is 90. But how do you write your solution? It's r comma theta. So when sine theta is 90, sine of 90 is 1. So what is the radius? 2 times 1, which is 2. And that should work for the second equation too. What sine of 90? 1 plus 1 is 2. So 2 comma 90 is your solution. And all solutions are common points, right? What about the other 3? You can do it algebraically. This should just work for one of the equations. Yes? No, it could be more. Yeah, yes. So let's graph this too. So I have 2 sine of theta. And I have 1 plus sine of theta. And I don't think I have to change the window, right? Because it's a smaller. So watch this again. You see? They crashed. Did you see it? They crashed there. That was our solution. And what about the other point? Did it crash again? No. So this is just a common point. So how do you look at it on the table? Second graph. Whenever you have same r's, that's a solution. But now we want to know where this point is, right? That is when the radius is, it's not always 0, 0. It won't always work. It's when the radius is 0. So when does radius become 0? When does radius become 0? Here. So actually it is 0, 0 for this one. So this is common point.
0, 0, and 270.
Yeah, where else? Is there any other point where the radius becomes 0? What about 180? Yes, right? Just for the first equation. So this is also a common point. What about 270 and negative 2? We have to go, oh, yeah, right here. You see 0? Is it also a common point? Yes. But let's see. -2, yeah, 270, but -2 here. That's also a common point.